All right, now let's summarize the objective of interfacing our sensor with a relay or a contactor device. Okay, reason one is because, like I said before, whenever I want to purchase this sensor, you should check out for two major things. One, the rating of the transmission strength. The rating of transmission strength is the rating of the contact to control your logic. Another one is the voltage. So always check the nameplate, check the voltage range, also check the strength. Like the one I showed you, this particular one, this one, the current of this one is just 30 milliamp. All right, 30 milliampere. That is the current rating. Is not enough. Okay, is very small compared to other type of sensor transmitting strength. Okay, so because of that now, I will have to interface this with a relay before I meet a contactor. That is for a very big contactor. All right, now let's tag this contactor to be 400 amps. Okay, let me now put 400 amps on that. Let's say I have 400 amps contactor here. Now that is the size of this contactor. All right, then okay, now let me also give the rating of this relay. This relay, the nameplate of this one is always the strength, the transmitting strength of this one is also let me check. I will check the nameplate of this to be precise, okay? But I know that the coil of this should be something in the neighborhood of let me say 50 watts. Okay, let me just say 50 watts. The coil of this relay, let me say 50 watts. All right. All right, then the contact strength, the current carrying capacity of the contact is always between 5 amps to 10 amps or 5 amps to 7 amps. Okay, yeah, it's then the contact current carrying capacity of the contact of this particular relay is between 5 amps to 7 amps. Then the coil, the strength, the wattage of the coil, let's take it to be 50 watts. All right, I'm not certain, but let's just work with 50 watts. I just want to we are heading to somewhere. Then this one, the contact strength is 400 amps. Okay, so if 400 amps is this particular contactor, then let's say the coil should be around 200 watts. Okay, all right, let's work. Let me just frame up this then so that we make a calculation. So if I have a 200 watt, if I have 200 watts, it's going to be divided by 230. I'm using 220 for the coil. So my current for this is going to be 0.89 amps. Okay, this is in ampere, not in milliamp. This is direct ampere, not milliamp. This is 0. What did I get again? Just hold on. Yeah, 0.86, 0.86 ampere, not milliamp. Milliamp is for thousands. Okay, so this is higher. This current is higher than what this can take. Remember, this is a milliamp. This is 30 milliampere. 30 milliampere. That is the strength of this transmission rating. So 30 milliampere compared to what I have here. So this is high. This current is high. This is in ampere. This is in milliampere. Okay, so if I want to convert this to this, it's going to be 0.00005. That is intense. Okay, so this is higher. So this contactor, this sensor cannot power this coil. That is if I'm using 400 amps. I'm just giving you a narrative. Okay, all right. I'm just giving you the reason why we interface a relay before we power a contactor, some certain bigger contactors. All right. So That is that. So because of that now, I'm going to bring this before I power this contactor. So bringing this is going to be 50 watts. All right. So if we say we want to check the current carrying capacity of this, the current rating of this, we are going to say 50, um, 50 watts divided by 230 as well. I have 0.2, and this one is still in milliampere, not even in ampere. This is milliampere. Okay, so it's very small. So in that case, I can now power my relay directly with the sensor. Then the output of this my relay is what I'll use to power my contactor. So where is the output coming from? It's coming from the contact. This one power the coil, and my transmitting voltage passes through the contact and the contact before it gets to this other contactor. So let's do the practical now. So that is the reason why we interface a sensor to relay before we get to our load, our driven load. All right. Uh, so let's do that now. So I want to have a switch here to pass through sensor. So I have my supply here. I have my supply here, and I have neutral here already. So what I'm going to do, I will power my switch, move from here. Sorry. Remember that this sensor is using DC to transmit. Meanwhile, here we are using AC to this. All right. Let's go one after the other. Supposing we are using DC, including this DC, including this DC. All right. Let's finish with the DC. Then we'll now come. I'll now show you again how we can change this connection using DC signal here and using AC here to power our contactor. All right. Let's finish the whole of this using uniform voltage. After that, we do another exercise that this relay is going to be DC and this contactor is going to be AC. I repeat again, we're going to make a connection that this one, this particular relay, interfacing relay, is going to be DC, and this one, our relay sensor, is also a DC. Meanwhile, our result, our output result, where we are heading to, is going to be AC driven. After that, we're going to do another exercise that only the sensor is going to be DC. This other interfacing relay is going to be AC, and this one again is going to be AC. Okay, all right. So let's just take it sequentially. Just pay attention. Now, this is my DC source. Let me change this to okay. This is going to be AC. Don't worry. Don't worry. Let this be DC. And let this be AC. This is going to be AC. Now, I want us to get take this one close. This one is going to be also DC. So this one is coming here as my supply. Get to this place. Remember, I need DC to come to this area. All right, I need DC. So here is AC already. I need AC here too, and this one is going to be AC, and this one is DC. So what we are going to do now is get our positive supply first. We need our positive supply here. We also need our negative supply here. Now we need Like I said before, let's work with uniform voltage, and later I will teach you how to use multiple voltage to get to where you are going to. All right, so this is my positive. Our transmitting supply is this. Now I take my supply, I feed my switch. Sorry. This my mouse is disturbing. Just hold on. All right. Okay, that is the first step to feed my sensor with the required voltage. Now I have my output here. I have my output here to feed my, keep this here. This is my output going to my relay device. Just hold on, let me take this up a little. This one is coming to my positive of my relay. Okay, let's understand the configuration, terminal configuration of this relay. They use the symbol. Now take a look at this. 13 terminal 13 and terminal 14 is my input, the coil input terminal of this relay. All right. Then terminal 9, 10, 11, and 12, they are the common terminals. Common terminals. Okay. So I have a 4 circuit here. 1, 2, 3, 4. 4 circuit to work with. Terminal 9 to 12, they are the common terminals. Then 4, 3, 2, and 1, they are normally closed, NC terminals. Then 5, 6, 7, 8, they are NO, normally open terminals. All right. Okay. I treated the relay configurations and function before, so you should be familiar with this, all these terminal configurations. We used relay before to put on lamp and know how to configure NCNO. We also treated timer, relay timers. Okay, we did all that: on timer, on delay timer, off delay timer, and the multi function timers. We did all that. Check my page, you see them. All right. So we just inputted power to this relay. So we need our output from here to feed the contactor. But before then, let's just test the relay if it's going to be energized first. Okay, let's test the relay. Then the next step is to now power the contactor from our relay. So let's simulate and see if this one will get energized. Okay, so okay, now you see output coming out. Output is coming out, but it's not powering the relay. Let me confirm from. Let's confirm from. Let's confirm from this. Okay, let's confirm from this symbol side. I'm not getting output to the relay. Okay, let's check if we have NPN PNP. Okay, so that means we have open circuit somewhere. Output is coming from the sensor, but the relay is not being energized. Let me see. Okay, the 14, just hold on. This 14 not on. All right, let's try again. The output is not coming up. Let's see. All right, there is open circuit somewhere. Let's see. This one is not connected. There is one advantage of simulation. If the job is not, if the simulation did not pass, even if you carry out the practical implementation, it will fail as well. So that is a great advantage of simulation. If you don't have your terminals firmly terminated, you have issue. All right, so it's true now. Let's find out. Okay, it's true now. So here, the negative is true now. All right, and then we have to swap the polarity. Okay, this one is terminal 14. This one is terminal 13. So we have to swap this polarity. So terminal 13 is supposed to be positive, then 14 is negative. So we have to interchange the polarity, otherwise it will not work. So let's see if we got what we want now. Now watch this terminal. This is 9, 10, 11, and 12. You will see them change state. Moving from 1 to 5. This one move from 2 to 6. This one move from 3 to 7. This one move from 4 to 8. And here we change and change signal. Here we show a sign of red. Okay. So watch now. You see the terminal changing. Watch this place. See how the terminal swap from NC to NO. Then see how power goes into the coil. Watch again. You see the function now. Okay. So each of the circuit is changing state. So that is how the sensor will transmit power from the receiving end to the destination. So sensor now senses whatever thing that is designed to sense, whether it's designed to sense object, metallic object, or absent of motion or whatever, and maybe voice, whatever thing that is designed to sense, it will now trigger the output by giving you output from this. So the output now is what you are going now to use to activate a relay. Then when a relay is being activated, then the contact will close. So the closing of the contact is what we are going to use now to power our contactor. Okay, so let's change this view to 3D. Okay, so let's simulate again. Watch this indicator lamp come up. Okay, see it. See the indicator light showing that the relay is being powered. Now, if that is done, now let's now power our driven load, being the contactor. Okay, so how do we do that? The contactor now is not an issue. It can be AC, it can be DC, it can be any voltage. It can also be 400 volts. Because we are using relay to interface, irrespective of the source of the voltage coming here, is none of our business concerning contactor. What we are using is the contact. We are using contact a transmission to send power here. So contact signal is what we are using. So contact now is just a dry contact. It does not have any voltage. Dry contact. Okay. So whichever transmitting voltage you are using to feed contactor, it does not matter. But let's use AC. All right. Let's use AC. So let's create another supply here. I have supply here. I have supply here. Okay. Then I'm going to take away this. So I have a neutral here to feed to my contactor. Then the supply is going to be live conductor. Okay. Meanwhile, we use DC here. We also use DC here. So we are using AC here. I want to show you that configuration as well. So because of that, let's go back to the contact. Let's come back to the contact configuration so that we know the circuit we are going to use. Now let's use which circuit that the both terminal will be coming from this direction. Let's check. 12. I don't have 12 here. I don't have 11. I don't have 10. I don't have 9 here. Okay. Let's go back here and find which one is free. Okay. The whole of the common is linked already. The whole of the common, I linked them already. 9, 10, 11, 12, I linked them up. So let me send my supply to them. This is my supply. So I send my supply to the common. The whole of the common is linked already. I link them up. So let me power them with this. Pay attention, please. Let me show you what I did. Look at the common. Common 12, 11, 10, and 9. I link that they are the common terminals to complete the circuit here. So I link them up using a common signal. That is this particular supply. I link them up. If you want to use different voltages, you don't have to link the commons. It can be different voltage. This one can be 110 volts. This one can be 220, 230 volts. This one can be 12 volts, and this one can be 24 volts. It can be separate. They are not having any connection with each other. They are on their parallel way. Okay, they are all parallel method. So in that case, I can now choose any of them. Let me choose 4. Let me choose, okay, let's choose 8. Which one again is smaller? I have 2 as well. Okay, 2. Let's move from 2. All right, I want to feed my contactor from 2. Okay, then my neutral will come from this direction to feed my K2, my A2 rather. All right, the contactor connection is completed. A2 is coming from neutral. A1 is coming from my relay. So let's test now. You see this one turn red when it is connected. Here we show red. So let's simulate and see what we have. Look at it. It's closed already, but that is not what I want. I want it to close when the switch, when the sensor is activated. So we're going to change it from 2. Oh, sorry, 2 is normally closed. So I'm going to put it, we're going to take it from 6. Sorry. It's actually 2, but 2 is not having that terminal. Look at terminal of 2. The terminal of 2 is this. So we pick a wrong terminal. Look at terminal that belongs to 2. Okay. The way it is just a zigzag, so you cannot actually identify which terminal is having these dotted lines. So let's find out again. Okay, let's see, activate this one. Okay, look at it now. So this one is closing now, and the relay is closing as well. This one is activated now, and relay, look at the sensor. Once sensor senses any object by clicking the switch, here will come up. Look at this one is on, this one is on. Look at them. Okay.